In today's lesson, what is structural geology? And what are the working areas of the structural geologist? You will learn these topics. Let's start our lesson right now. What is structural geology? Structural geology is an integral part of the geological sciences, and it focuses on the study of the physical and mechanical properties of rocks and their deformations, as well as the processes that have caused these deformations. It aims to understand how the Earth's crust has evolved and changed over time, and how it has been shaped by geological forces such as plate tectonics, volcanic activity, and erosion. In order to study the structures in the Earth's crust, structural geologists use a variety of methods and techniques. One of the most important methods is field mapping, which involves mapping the rock units and their structures in the field. This can be done through the use of various tools, such as hand lenses, compasses, and measuring tapes, to observe and measure the orientation, size, and shape of the rock units and their deformational structures. Another important method used in structural geology is geophysics, which involves the use of various instruments and techniques to measure the physical properties of the Earth's crust. For example, seismology, which is the study of earthquakes and their associated waves, is a crucial tool in structural geology. Seismologists use seismograms to record the motion of seismic waves as they pass through the Earth's crust, which allows them to determine the location, depth, and size of geological structures such as faults and folds. In addition to field mapping and geophysics, structural geologists also use petrology, which is the study of rocks, to analyze and interpret the structures in the Earth's crust. Petrologists examine the mineral composition, texture, and structure of rocks to determine how they were formed and how they have been affected by geological processes. The information gathered from field mapping, geophysics, and petrology is used by structural geologists to build models of the Earth's crust and its evolution. These models help to explain the processes that have caused the deformations in the Earth's crust, as well as how the Earth's crust has changed over time. In conclusion, structural geology is a fascinating and important field that plays a crucial role in understanding the Earth's crust and its evolution. By using various methods and techniques, structural geologists strive to uncover the secrets of the Earth's past and how it has been shaped by geological forces. What are the working areas of the structural geologist? Structural geologists study a wide range of areas, including faults and faulting. Structural geologists study faults, which are fractures in the Earth's crust where rock units have moved relative to one another. They examine the causes and effects of faulting, including the mechanics of how faults form and the forces that drive them. Folds and folding. Structural geologists study folds, which are deformations in rock units that result from compressive forces. They examine the geometry and kinematics of folds, as well as the processes that cause folding, such as orogenic uplift and tectonic activity. Joints and jointing. Structural geologists study joints, which are fractures in rock units that result from tensional forces. They examine the orientation and spacing of joints, as well as the processes that cause jointing, such as weathering and erosion. Metamorphism and metamorphic rocks. Structural geologists study metamorphism, which is the process of transforming rocks from one type to another through the application of heat and pressure. They examine the relationships between metamorphism and tectonics, as well as the mechanical and chemical processes that cause metamorphism. Tectonics and plate boundaries. Structural geologists study tectonics, which is the study of the large-scale deformation of the Earth's crust. They examine the different types of plate boundaries, such as divergent, convergent, and transform boundaries, and the processes that occur at each type of boundary, such as faulting, folding, and volcanic activity. Volcanism and volcanic structures. Structural geologists study volcanism, which is the study of volcanic activity and the associated structures that form. They examine the different types of volcanic structures, such as calderas, volcanic cones, and ash deposits, as well as the processes that cause volcanism, such as magma generation and eruption. These are just a few examples of the areas that structural geologists study. They use a variety of methods and techniques, such as field mapping, geophysics, and petrology, to analyze and interpret the structures in the Earth's crust. The information they gather helps to provide a deeper understanding of the Earth's history and evolution, as well as the processes that continue to shape the Earth today. Don't forget to subscribe to my channel, turn on notifications, like my videos and write a comment under my videos.